I want to thank you for clicking on this video about how gravity works. You know, people always ask me why do I make these videos, and it's because of people like you who click on them. So thank you very much. If you haven't subscribed yet, well, there's a big red button down below that says subscribe. So why don't you click on that as well? But enough of that. Let's get into today's video. In this video, I'm going to try to answer the question of how does gravity work? Now, when most people ask me this question, they expect me to talk about Newton's law of universal gravitation or Einstein's general theory of relativity. But you know what? Those two theories don't actually tell us how gravity works. They only tell us how it behaves. So I think we need to go deeper. We need to ask ourselves, what is causing the gravitational force? What is causing gravity? Well, there's one thing in the universe that has a gravitational force, and that is anything that has mass. That's everything. Everything in the universe has a gravitational force. Now, here's something interesting. When you're standing on the surface of the Earth, we know that you have a gravitational force pulling you towards the center of the Earth. But the Earth also has a gravitational force, and that force is pulling the center of the Earth towards you. The problem is, since the Earth is so massive compared to you, its gravitational force is much stronger than your gravitational forces on the Earth. So you don't notice that the Earth is being pulled towards you. In fact, you're actually pulling the Earth just as hard as the Earth is pulling you. But again, because the Earth is so much more massive, its gravitational pull is much greater than yours. So we only notice that we're pulled towards the Earth. Here's an interesting consequence of this. If you were to double your mass, you would double the gravitational force that you exert on other objects. But the gravitational force that other objects exert on you would also double. So if you doubled your mass, you wouldn't notice any change in the gravitational force acting on you. Now this might seem counterintuitive, but let me explain it this way. Let's say you have two 100 kilograms objects and they're far away from each other. Then let's say that you bring those two objects together and they're now only 1 meter apart. Each one of those objects is now feeling a gravitational force due to the presence of the other object. The force depends on the masses of the objects and the distance between them. Turns out that if you double the mass of both objects, the distance between them stays the same, then the force between them doubles. So even though you doubled the mass of the object that you're standing on, you don't feel twice as heavy. This is because the Earth is so massive that its gravitational field is nearly constant across its surface. So if you were on the surface of the Earth and you doubled your mass, you would still feel the same gravitational force, but the Earth would be pulled a little bit closer to you. Okay, so you might be thinking, if all objects have a gravitational force, then shouldn't we be able to feel the gravitational force of other objects? Yes, we should. We can, if the objects are massive enough. For example, you can definitely feel the gravitational force of the moon on the ocean, which causes tides. But most objects aren't massive enough for us to notice their gravitational pull. Why is that? Well, here's the issue. For every action, there is an equal and opposite reaction. So if you were on the surface of the Earth and you jumped up, the Earth would fall back towards you. Of course, this doesn't happen because the ground beneath your feet prevents the Earth from falling back towards you. But if you were in outer space and you jumped up while not touching anything, then the Earth would fall back towards you, and you would fall back towards the Earth. And this means that there's no such thing as being weightless in outer space. You're actually falling towards the Earth with a velocity that's perfectly matching the velocity that the Earth is falling towards you, so you don't notice that you're falling. But you're actually not weightless. You're re-experiencing weightlessness because the Earth is falling towards you just as fast as you re-falling towards the Earth. So in reality, you're never truly weightless. But what happens if you had a really massive object in outer space that wasn't touching anything? Then you'd experience a significant gravitational force due to that massive object. For example, if you were near a black hole, you'd feel a very strong gravitational force due to that black hole. So this leads us to an interesting question. What exactly is this gravitational force? What is it made of? We don't really know, but we do know that it's not made of particles. Why is that? Well, if it was made of particles, then those particles would have to travel at the speed of light. This is because if you have a particle that has a mass and it s traveling at a velocity, that s less than the speed of light, then you could always accelerate that particle and thus increase its velocity to the speed of light. So if the gravitational force was made of particles that were traveling at a velocity less than the speed of light, then you could always increase the strength of the gravitational force by accelerating the particles that carry it. but we know that you can't do this. The strength of the gravitational force is fixed. It doesn't just depend on the mass and the distance between the objects. It also depends on the strength of the gravitational constant, which is a fundamental constant of nature. So the gravitational force cannot be made of particles. But this leaves us with another question. What is this mysterious gravitational force made of? Well, we don't really know, but we do know that it must be a manifestation of some kind of energy. After all, energy comes in many forms, right? There's kinetic energy, potential energy, thermal energy, electrical energy, and so on. Could it be possible that this mysterious gravitational force is just another form of energy? Oh yes, it could be possible, but it can't be any kind of energy. Why is that? Well, remember that for every action, there is an equal and opposite reaction. So if the gravitational force was just another form of energy, then there would be another form of energy that was equal and opposite to it. And we know that this can't be the case because energy is conserved in the universe. So if there was an equal and opposite form of energy that was canceling out the gravitational force, then energy wouldn't be conserved in the universe. So what kind of energy could it be? Well, the answer is it has to be a type of energy that doesn't have an equal and opposite counterpart. And the only type of energy that fits this description is vacuum energy. Vacuum energy is the lowest possible energy that can exist in a region of space. And it's associated with virtual particles that pop in and out of existence. Virtual particles have an interesting property in that they can't be isolated in free space. You can't go out into outer space and find a single virtual particle, but you can detect the effects of virtual particles if you have a very sensitive apparatus. And one of the ways that you can detect the effect of virtual particles is by using a device called a Casimir effect. The Casimir effect is a really cool effect that I talk about in one of my other videos. You can check it out after this one if you're interested. But basically, if you put two plates close together in a vacuum, then you can actually feel a force pushing the plates apart. And this force is caused by virtual particles that are popping in and out of existence between the plates. The plates prevent those virtual particles from popping into existence between the plates, but they still pop into existence on the outside of the plates. And the effect of those virtual particles that pop into existence on the outside of the plates is to push the plates apart. So here's where it all comes together. We think that the gravitational force is actually caused by vacuum energy. And we think that vacuum energy is constantly flowing from regions of higher vacuum energy to regions of lower vacuum energy. And we think that this flow of vacuum energy is what causes the gravitational force. And we think that the reason why we do want to notice this flow of vacuum energy is because it's happening at the speed of light. And we know that it's happening at the speed of light because VA actually detected gravitational waves, which are ripples in this flow of vacuum energy. This all sounds pretty crazy, but it actually makes sense if you think about it. If the gravitational force is caused by this flow of vacuum energy, then it would make sense that it doesn't have an equal and opposite counterpart because vacuum energy CAU and be destroyed. It can only be converted into other forms of energy. So I hope this video helped you understand how gravity works. You know, I'm always amazed by the complexity and beauty of the universe. I'm so glad that you're here learning about it with me. Thank you so much for watching, and I'll see you next time.